Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 10 on determining the equations of trigonometric functions. And boy, equations is the right term because every trigonometric function has an infinite number of correct equations that can describe it. I hope you've been with me for the last few lessons where we've discussed all sorts of different issues that we will review at the beginning of this lesson. But if you haven't been with me for amplitude, midline, period, frequency, and horizontal shift, you might want to go back and make sure that you look at those. Otherwise, today is going to be a little bit of a rocky journey. So let's jump into it and start coming up with some equations. 4 basic transformations. We have now looked at 4 different transformations of our basic sine and cosine functions. They are summarized in the formula box below, so let's talk about them. General trigonometric function equations. A sine or cosine function can be fully modeled with y equals a times the sine of b times x minus h plus k, or y equals a times the cosine of b times x minus h plus k, where the absolute value of a is the curve's amplitude, b is the curve's frequency, sometimes known as the angular frequency, h is the curve's horizontal shift, and k is the curve's vertical shift, also known as its midline. All right, so each one of these transformations we have discussed in previous lessons, and we've really talked to them about them a lot. All right, so let's jump into exercise number 1, where we see some, but not all of them. Exercise 1. Given the function f of x equals 6 times the sine of pi over 8 times x plus 2, answer the following questions. Letter A. State the minimum and maximum values of the function. All right, well, let's review how this is done. So one thing that I know immediately when I look at this equation is that y equals 2 is what's known as the midline of the function. All right, in other words, this trigonometric function rises and falls an equal amount above and below the horizontal line y equals 2. Now, how much does it rise and fall above the line y equals 2? Well, it falls that amount. So the amplitude, which is that distance that it rises above and below the midline, is equal to the absolute value of 6, which is just equal to 6. This allows us now to think about the minimum and the maximum values of the function. Specifically, y minimum is going to be equal to our midline minus the amplitude, which, is negative. And our maximum is always going to be the midline plus the amplitude, which ends up being 8. So in other words, this curve, right, has a low of -4 and a high of 8. Letter B. Determine the period of the function. Recall that the period is the horizontal distance that it will take for this curve to start to repeat its basic waveform. Now, the period doesn't really show up in the equation per se. What does show up in the equation is what's known as the frequency. All right? B, which is known as the frequency, and you do need to know this terminology, is equal to pi over 8. Now, the frequency is the key to calculating the period through the equation b times p is equal to 2 pi. So I can now say that pi divided by 8 times the period is equal to 2 pi. This will now let me say that the period is equal to 2 pi times 8 over pi. The pi's cancel, as they often do in these situations, and I'm left with a period of 16. So that means that every 16 units along the x-axis, this curve will repeat its basic waveform. And that's going to allow me to scale the x-axis in an appropriate way. Now let's take a look at letter C. Draw a sketch of f of x below for 2 full cycles of the function to the right of the origin. Label the x-axis appropriately. Verify using your calculator. Now, we've talked about this in the past, but let me reiterate something that's very important about trig functions. All right, trig graphs come in quarters. Or maybe I should say we want to think about them in terms of quarters. And so the first thing I always do when I decide how to graph something in terms of a sine or a cosine curve is I take my period right? And I divide it by 4. That's 16 divided by 4, and that's 4. All right, this is going to be my scale on the x-axis. All right, so every unit on the x-axis for me is going to represent 4 units. It's always going to be representative of a fourth of a period. All right, in other words, I'm going to go 4, 8, 12, 16, 20, 24, 28, 32. All right, now I don't necessarily have to mark all of those, okay? I should certainly mark the 16 and the 32, all right? But I also kind of want to think about what that other scale is. So maybe I will erase that and all of these, right? So I'll have the 4 there so that I can really see what my x-axis is scaled in. And then I'll mark off my 16 and my 32. Now, how do I want to take it from here? The next thing that I tend to do, and let me draw this actually in red, is I tend to graph the midline, and I'll explain why in just a moment. And I do it in dashed. Okay, so y equals 2. It's not really there if I draw it in dashed, it's just a guideline. That's going to be the horizontal line that my curve rises and falls about. Now, what is my curve? Well, it's sine, okay? Sine starts at its midline and then rises out of it. So in other words, the first point I'm going to graph is right there. Now, 1/4 of a period over, 4 units over, I'm going to hit the maximum, which is going to be 6 units above my midline, right? It's going to be right up here at 8. All right, then when I go another 1/4 of a period over, I'm going to be back at my midline, so I'm going to be back at y equals 2. Then I'm going to move another 1/4 of a period over, and I'm going to be at my minimum at -4. And then I'm going to move one more 1/4 of a period over, which means I will have gone through a full period, and I'll be back at my midline. Now, it does say 2 full cycles, but let me throw in the first cycle, and then we'll put in the next one. That's about as good of a graph as I can get, even though I missed it right there. All right, now let me go through the rest of it pretty quickly. Another 1/4 of a cycle over at the max, back to the mid, back to the min and the mid. And I'm done. And there's my 2 full cycles. Let's verify using our calculator really quickly. All right, let's bail out of here. Let's go into here. What was my curve? My curve was 6 times the sine of, let me actually put this in terms of a fraction so that I can really see it there. Make sure to get that x not in the denominator. And then I've got plus 2. There's my curve, enter. Now I want to get my window to look exactly like my window here. So I'm going to go into Window, Window Settings. I'm going to actually include a little bit to the left of the y-axis so that I can actually see the y-axis. And I think I'll actually stop it at 32. I know that my graph paper goes a little bit further, but I just want to see those 2 full cycles. Remember, I want my scale along the x-axis to be that 1/4 of a period at 4. Then it looks like I'm at -5 all the way up to 10. And I'll go by ones. And there we have it. Now again, I know that I have that additional portion right here. The only reason I did that is if I don't, what the TI Inspire will do is it'll literally put my y-axis right there on the leftmost portion of my screen, and I actually won't even be able to see it. So I kind of like to be able to see that particular thing. If I actually want to see the midline as well, which is kind of cool, I can go into Graph Entry Edit, put my function in, do this, all right? And then what's really nice is I can really see that curve rising and falling 6 units above and below my midline. I could even make that midline into a dashed line if I really, really wanted it. Where is that? I think I can do this, attributes, do this, and look at that. I can even make it dashed. You probably can't even see that very well. Anyway, it is dashed, trust me. I feel like I should now make it bold and dashed. All right, the calculator technology. So very systematically moving through 3 of the 4 transformations, right? The vertical stretch, which gives us rise to the amplitude, the vertical shift, which gives rise to the midline, and then the horizontal compression or stretch, depending on how you want to look at it, which gives rise to the frequency and the period. The one thing that isn't in this particular exercise is our horizontal shift, which is definitely the thing that gives us the greatest headaches when it comes to these particular equations. Let's keep going. Let's take a look now at determining an equation without a horizontal shift. So in our last exercise, we had an equation and we wanted to graph it. Now what we're going to do is we're going to go in the opposite direction and we're going to take a graph and we're going to come up with an equation, but we're going to go on the premise that we don't want to have a horizontal shift in this one. So let's take a look at exercise number 2. Determine an equation for the graph shown below that does not contain a horizontal shift. Show the work that goes into finding all the parameters of your equation. All right, so if we don't have a horizontal shift, then we're looking at either y equals a times the sine of bx plus k, or y equals a times the cosine of bx plus k. And we'll decide whether we want sine or cosine in just a little bit. We don't have to do that. We don't have to figure that out, sine or cosine, before we figure out the a, the b, or the k. We can figure out all of those right up front. And to me, the easiest things to figure out up front aren't a and k, but the absolute value of a and k. All right? So why not do k first, right? K is the midline, and you will always be able to find that by finding the average of the maximum and the minimum y values. And that should make sense to you, right? We're talking about the midpoint from geometry, but just the midpoint from a vertical perspective. So my minimum y value is 6, my maximum y value is 16, so I can just do 6 plus 16 divided by 2. That's 22 divided by 2, and that gives me a midline value of 11. All right, and you can kind of see it if you really sort of sketch it on here in maybe a different color and right. So there's my y equals 11. My curve is rising and falling an equal amount about that horizontal line. So now let's think about our amplitude. Now there are a ton of ways to think about the amplitude. You could even think about the amplitude before you think about the midline. All right, and I don't want to restrict the way you think about it. A lot of students will say, well, I know the midline's at 11, and since the high is 16 and the low is 6, it's clear that it's rising 5 units above and dropping 5 units below. That's awesome. So you could do maximum minus midline gives me the amplitude. You could do midline minus the minimum gives me the amplitude. Another way of finding the amplitude, if you really, really love formulas. Now again, this is the absolute value of a, not necessarily a, but it will always be y max minus y min divided by 2. You see, if I take the maximum y value and I subtract the minimum y value, that will always give me this distance, right? So that distance is always found by taking the maximum minus the minimum. In this case, that's 16 minus 6 divided by 2, because we only want half of it. That's 10 divided by 2. And that's an amplitude of 5. Now again, I want to be very clear. There's absolutely nothing wrong if you're saying to yourself, well, I'd rather do the maximum minus the midline. Good on you, right? That's fine. Nothing wrong there, okay? Or if you love doing the midline minus the minimum, also awesome. Nothing wrong, okay? But the standard way of finding the midline is by averaging the max and the min. The standard way of finding the amplitude, the absolute value of a, right, is by doing the maximum y value minus the minimum y value, giving you this total vertical distance, and then dividing it by 2 to give you just this, right? And again, just to be very clear, right, this is a. All right, or absolute value of a. A and absolute value of a are slightly different, especially in this problem. All right, now we'll figure out whether we want a to be positive or negative in a moment, but let's also figure out what the b is, right? The b is the frequency, and yet again, the frequency does not show up on the graph, but it's related to the period, Okay? So one thing I can see immediately from this graph is I can see what the period is. The period is this distance, all right? And the period is 3 pi, all right? Sometimes we have to do a little bit of calculation to figure out what the period is, but it's not challenging in this one because I can literally see it right there. If I absolutely had to, I could take this x-coordinate and I could subtract that x-coordinate, right? I could actually do 9 pi over 2 minus 3 pi over 2, which would be 6 pi over 2, which would be 3 pi. But it's also pretty conveniently just sitting right there. Now again, that's the period. It's not the frequency. But we know that b times p is equal to 2 pi, right? So that means 3 pi times b is equal to 2 pi, which means that b is equal to 2 pi divided by 3 pi, in which case the pi's cancel, and my frequency is 2/3. All right? So now we almost have everything, right? We've got the value of b straight up, it's 2/3. We've got the value of k straight up, it's 11. We know the absolute value of a is 5, but that means it could be 5 or it could be -5, and we haven't yet decided whether it's a sine curve or a cosine curve. So here's the key. If I don't want a horizontal shift, and it says does not contain a horizontal shift, then I have to base this off of the cosine. And the reason I have to base it off of the cosine is that if it was based off of the sine, it would be starting at its midline. All right? Caught that? So the sine starts at its midline. The cosine either starts at its maximum, if a is positive, or its minimum, if a is negative. All right? So in this particular curve, we have to use cosine, must use cosine, because no horizontal shift. Now, if we had a horizontal shift, as we'll see in a little bit, we could use either one of them, all right? And a must be -5 because cosine starts at its min, and therefore we have y equals -5 times the cosine of 2/3 x plus 11. All right, y equals a times cosine bx plus k. Make sure that negative really is sitting there. And yet again, what's really cool about this is that you can easily check this on your calculator. Now, it's maybe not so easy to sort of check these particular points, right? The 3 pi over 2, the 3 pi, the 9 pi over 2. But given the fact that this thing is kind of, dimensioned in terms of 0 to 20 and 0 to 18, let's take a quick look. All right, let me kind of go into this. I'm going to open up a brand new document. I want to go to my graph. For F1, right, it was -5 times the cosine of 2/3 times x plus 11. All right, that looks terrible, right, because of my window. Let's go into my window. Let's go into window settings. I'm going to add a little bit, as I said, to the y. I'm going to go -1, it looks like, to 18. I think I'm going to put my scale in as 1s. I mean, I could have those 5s marked as well if I wanted to. My y min, I'm going to actually put a -1 in as well, but I'm going to go up to 20. And I'll also have that scale by 1. And there it is, right? So I can really see that I've got basically the correct curve. Now again, what's a little bit tricky are these maximums and minimums where the x-coordinates are in terms of pi. That's a little bit harder. If I really wanted to verify that I nailed that one correctly, I'd have to go in and use the maximum or minimum command. It would give me an ugly answer because, as we know, pi is irrational, and then I'd have to sort of check that decimal version. All right, so that's a little bit dicier in that sense. Okay, that being said, let me bail out of here. And let's go on to the next problem. Now, let's talk about multiple equations. Because of their repeating periodic nature, each trigonometric graph can be described with literally an infinite number of algebraic equations, all right? And that is not just a nightmare, by the way, for students. It's also a nightmare for teachers because, when I'm making up an answer key for something, it's pretty hard to put down every answer. It really is, because there's an infinite number of them, and that would take me forever. Let's talk about exercise number 3. Little math joke for you. A trigonometric curve is shown graphed. Letter A. Determine the amplitude, the period, the frequency, and the midline values for this function. All right, so we're going to start just like we did before. We want to figure out the absolute value of A. We want to figure out our K. We want to figure out our P. We want to figure out our B, right? And then we'll figure out horizontal shifts and whether we want to use sine or cosine and all that stuff. Pause the video now and do exactly what we did in this particular problem. I want you to come up with the K, the absolute value of A, what the period is, then what the frequency is, and then we'll get into the hard stuff. All right? Pause the video now and see what you can do. All right, so it's always a debate for me whether I want to start with the midline or the amplitude. I never start with the period and the frequency, but that's just me. I actually really like to start with the midline, the K value. I find it, really kind of simple to basically take the minimum value, which is 6, the maximum value, which is 22, and divide by 2. That's 28 divided by 2, and that gives me 14. I kind of like doing that right from the get-go because I can then draw my midline on. It may not be the most accurate thing, but I can draw it on there, and it kind of gives me a nice physical sense for at least something or some of which is going on, right? So this curve is rising and falling by a certain amount above and below y equals 14. Yet again, you could just do 22 minus 14 or 14 minus 6 either way and get the amplitude, or you could use that classic formula, the amplitude being the maximum, 22 minus the minimum, 6 divided by 2. That would be 16 divided by 2, and that would give me an amplitude of 8. All right? And those two are just easy. They are literally addition, subtraction, divide by 2. That's it. It feels a lot like some of those circle formulas from geometry. But let's block that out from our memory. Okay, so now we have to think about the period. All right? Now that always tends to come next. Now before, it was really easy to just read the period off of the graph. This one is not so easy, and the last thing you want to do is assume that the period is 18, because it's not. In this case, the easiest way to figure out the period, maybe the only way to figure out the period, is to take these two x values and subtract them. That will work with any two consecutive maximums or minimums, and I can see that the period is 20 units, right? So it takes 20 units, 20 horizontal units. The period is always in terms of the horizontal axis, 20 horizontal units to go from this maximum to that maximum. So because the period is equal to 20, I can now say that the period times the frequency is equal to 2 pi. And that means that the frequency is 2 pi divided by 20. I'm actually really comfortable with leaving b as 2 pi over 20. I have absolutely no issue with that at all. Some of your math teachers might want you to reduce this and say that the frequency is pi divided by 10. But I actually almost like it better as 2 pi divided by 20 because then I can see the period just sitting there. 6 1/2 dozen of the other, 2 pi over 20 or pi over 10. Both work equally as well, even if you can't really see that 10 very well. All right, now, all of that is what it is no matter whether we choose sine or cosine. It doesn't matter what our horizontal shift are. Our midline value is 14, our amplitude is 8, and our frequency is pi over 10. And all three of those numbers are going to show up in our model no matter what we do next, okay? But let's take a look at what we're going to do next. Letter B. Assuming the function fits the form below, determine the value of h. Sorry, you probably can't even see that that's h. h. Check using your calculator. All right, so what is the form below? And this might be a little bit confusing, but what I want is I want a cosine value, and I want my a to be positive. Okay, all right. Now here's the key, Okay, because again, I could make this into a sine curve, which we're going to do in a little bit. All right, I could make it into a cosine curve where a is negative. There's a ton of things that I can do. I can even make it like this and have an infinite different number of values of h. Oh my goodness, okay? But anyway, what I want is I want a cosine curve and I want a to be positive. Now, keep in mind, right, that a cosine naturally starts at its maximum. Okay, and by starts at its maximum, I mean it normally has its maximum on the y-axis. Okay, so what you do here, if you want a cosine curve that has a positive a value, okay, then what you do is you look for your first maximum. All right, or any maximum for that matter. But I want my first maximum in this case, right there. So what I would need to do, the natural cosine curve, if I didn't horizontally shift it at all, but I had all of these other things, all right, all of these other numbers, the natural cosine curve would have its maximum here, but I want its maximum here. So I just need to shift it to the right 8 units. That's all I have to do. I just have to say, well, naturally the cosine curve would have its maximum here. I want it to be here. So I now need my h to be equal to 8. In other words, my final equation is going to be y equals, oh great, we're going to have two 8's in here, 8 times the cosine, that could have been designed better, Kirk, pi over 10 times x minus 8 plus, what was my k? 14. And again, my apologies for the two 8's. I'm now kind of annoyed at myself for that. This horizontal shift being 8 and this amplitude being 8 have absolutely zero, zilch, nada to do with each other. Bad, Kirk, bad. Anyway, so there we go. Now, let's actually take a look and make sure it's correct. Okay, and that's the beauty of things, right? That's the beauty of your graphing calculator. If you come up with a particular trig curve, let's say I made a mistake. Let's say I said x plus 8 instead of x minus 8. I can verify whether it's right or wrong because I've got the graphing calculator. It's just an issue of, do you care enough? Do you care enough to go into your graphing calculator, right, and check out and see if you got it right? So let's throw our curve in there. We've got 8 times, why do I keep doing that? 8 times the cosine of pi divided by 10. I gotta, oh, no, pi divided, oh, you've got to be kidding me. Again, no. Now go down. I like how I make the same mistake like 3 or 4 times in a row. X minus 8, parentheses, parentheses, plus 14. Plus 14. There we go. I have way too many parentheses there, but it doesn't matter. It's all good. Okay, so I still can't tell whether it's right or wrong because of my window. So let me just really quickly go back in here and scroll up so that I actually can see my graph. Now I go back out. That's right. I have an inner monologue going at all times, folks, all times. Menu. If you haven't noticed that yet, then that's not my issue. Okay, I want my y-axis to be on there, so I think I'm going to go -1 on the x, but then I'm going to go all the way out to 40. And I think I'm going to scale it by, oh, should I scale it by 10s or 5s? I think I'll actually scale it by 10s because that's what it's marked off on the x-axis. I'm going to go -1 to 25, and I think I'm going to go by 5s there. All right. And there we have it. Yeah, so we've got the entire curve there, right? It basically looks exactly the way I want it to. Not really sure why it's hitting all the way up there at the top. Menu, hold on, give me a second. Oh yeah, that's because I had my maximum at 22, which makes sense given that it goes up to 22. But there we have it. That one looks a little bit better. I want it to look exactly like this, so I want to have that maximum up there at 25 because the graph only goes up to 22, but I can now really see that it matches what I'm looking at right there. And again, I would even suggest throwing in the y equals 14 so that you can see that midline, that it rises and falls above and below. But now, let's get into the issue that that's not the only equation that could describe this, right? I sort of arbitrarily was like, okay, let's use cosine. Now let's take a look at exercise number 4. Given the graph above, answer the following questions. Letter A. What is the first x value at which the function hits its midline? Illustrate graphically. Well, let's actually throw that midline here, okay? So I know that I have it graphed on the one above, but I'm going to graph it again. That midline was at y equals 14. Right? And there is that first x value. Now, or at least the first point, okay? I need to know what the x value is, though, at that point. And I don't want to guesstimate it. I don't want to be like, well, I don't know. It looks like it might be 3 or 4, maybe it's 5, because maybe I've drawn this a little bit problematically, all right? Well, here's the key, right? The key is the period. Remember that the period here, right? The period is equal to 20. Now, I don't care so much about the period. What I care about is the period divided by 4. So if I take the period and I divide it by 4, 20 divided by 4, I get 5. Now, why is 5 so important? 5 is the distance that's going to, horizontal distance, that's going to separate the maximum from where it hits the midline. In other words, if I go 5 units to the left, right, then I'm at an x value of 3. By the way, if I went 5 units to the right, if I cared that much, right, then I'd be at an x value of 13. 1/4 of the period is an exceptionally important piece of information to know. So, what is the first x value at which the function hits its midline? X equals 3. And again, I get that because I know where the maximum's at. It's at x equals 8. I go 1/4 of a period to the left, and I'm now at x equals 3, and y equals 14, but they didn't ask me that. Now let's take a look at letter B. Determine a function that has the form y equals a sine b times x minus h plus k for the graph if a is positive. Verify using your calculator. All right, so in other words, we already know what the equation of this is in terms of cosine. But remember, sine starts at its midline and rises out of its midline. So if I had no horizontal shift, but I had the same value of the absolute value of a, which was 8, and I had the same midline, which was 14, and I had the same b, which was pi over 10, right? Then this curve would start on the y-axis. But now I just want to shift it so that it starts here instead. Again, normally the sine curve would start on the y-axis at its midline, unlike the cosine, which would start at its maximum. So I just need to shift it right so that it ends up corresponding to that. So in this case, I need h to be equal to 3. So y now will be 8 times the sine of pi over 10 times x minus 3 plus 14. Now, you might say, well, there's other shifts that would work. I could shift it to here. But then the a would have to be negative in order to force the curve to go down to begin instead of going up. If I did want a to be positive, I could also shift it all the way to here. I just don't know what the x-coordinate of that point is right now, but I could always take the x-coordinate of this point, which is 3, add the period to it, and the x-coordinate of that point would be 23. So that would also work, x minus 23. Remember, there's an infinite number of curves. Now, instead of like redoing all of this thing, I'm going to put this one in as f2 and see if it graphs right on top of this one. Let's take a look. So here we go, right? Menu, 3, function, f2. Everything is going to kind of remain the same. I've got 8, but now I've got the sine function. Now I've got my pi over 10, Ooh, I got it right that time. X minus 3 plus 14, darn it, plus 14, and there it is. It's a little bit annoying because the two equations ended up like sitting on top of each other as well, which was a bit obnoxious. But now what we see is we see exactly the same curve. I kind of wish it was in purple since I have red sitting on top of blue, but it just simply shows me the red instead. And again, I could put a third one in, right? I could put one in with a -8 times sine if I decided to shift it over to 13. Then it would go like this. I could put in a -8 with the cosine if I shifted it over 18 units, because then we would have cosine starting at its minimum value. An infinite number of correct equations. Is that annoying? You bet it is. But it's also the nature of periodic functions. Let's take a look at one last problem. Exercise number 5. For the function shown graphed below, determine two equations that could describe the function. Make one of them based on cosine function and one based on the sine function. Test both on your calculator. All right, great. So what I'd like you to do is start with this problem, figure out the midline, the amplitude, the period, the frequency. I would then graph the midline for yourself. I'd figure out what a quarter of the period is, just so you have that handy, because you know you're going to need it, right? And then think about sine and cosine. Think about whether you want your A to be positive or negative, all right, and take it from there. Pause the video now and see if you can come up with two of the infinite number of correct equations that describe this graph. So as always, I always begin with the midline and the amplitude because those do not depend, midline, amplitude, period, and frequency, because those don't depend on whether it's sine, cosine, or what the horizontal shift is. So let's do it. And these are a little bit messier because we've got some negatives, positives, we've got some decimals involved. It's all good. We can handle all of them. Let's first go with our midline value. All right. For me, that's always the easiest. That's going to be my minimum plus my maximum all divided by 2. That's going to be 10 divided by 2, and that's 5. As always for me, I love getting it graphed in there. So I'm going to graph y equals 5, just so I can really see that going up and down. Okay, going back, now I'm going to take a look at my amplitude, so the absolute value of A. Find it however you want to. I'm going to do my maximum minus my minimum. That's a little bit obnoxious because of that. But it does show me that that total vertical distance is 40 units. That gives me an amplitude of 20. Again, just keep in mind what that's telling you. 20 above and 20 below. Always just do a little physical check, right? You know, if I ended up doing something silly here like 25 minus 15, that would give me an amplitude of 5. And if I put 5 on here, I'd be able to look at it and go, well, that doesn't make sense. It's rising and falling way more than 5 units, right? And I could easily do that. You've seen me make tons of mistakes throughout this course. And if you've been with me with other courses, especially geometry, you've certainly seen me make mistakes there too, okay? Nothing wrong with making a mistake, but try to always reflect on your work as you move through to see if it's reasonable. All right, okay, there's my diatribe. Now, let's try to figure out our period, and from that, figure out our frequency. To me, probably the easiest way to figure out the period in this situation is to look at these two x values, all right? So what I'm going to do is I'm going to take those two x values, and I'm going to say that my period is going to be 72.5 minus 22.5, which happens to be exactly 50. All right? So my period is 50. Awesome. Right? I might even want to figure out what a quarter of my period is right now, but I think I'll leave that alone for the moment. Right now, I'm going to just try to figure out what my frequency is, given that that goes in the equation. My period times my frequency is 2 pi. That's going to tell me that my frequency is 2 pi divided by the period. Feel free to leave it as 2 pi over 50 unless your teacher is insistent upon you reducing it to pi over 25, but either one of those is nice. In physics, they will almost always leave the frequency as 2 pi divided by the period so that you can see the period there, but that's physics, right? Those crazy physicists. All right, now I've got 3 out of the 4 things that I need for my model, or maybe 3 out of 5, right? Because the other 2 things are 1, the horizontal shift, and 2, whether I'm using sine or cosine. Now, one thing I would like to know right now is what a quarter of the period is. And that's a little bit messy. P divided by 4, a quarter of the period, 50 divided by 4 happens to be 12.5. And that's a little bit messy, but it also probably explains why I've got this 22.5, 72.5. Now here comes the infinite number of answers, right? The infinite number of answers. I don't know which ones you've done, but let's try to go with the easiest one first. Now personally for me, the easiest equation to form is a cosine where the a value is positive. A cosine where the a value is positive. And that to me is easiest because that means I would just have to shift what would normally begin here. I would just need to shift it so that it's over here. Now this one's a little tricky because it almost looks like we're starting up here at 25, but we're not. It's a little bit offset. And it would be dangerous to think that we're starting at our maximum. But if you really look at the graph, it's very clear that it only intersects here at 24, not at 25. Point being, right, if I do an h value of 47.5, then I can use a positive a value on the cosine because it's starting at the maximum. So one nice particular curve to use is y equals positive 20 times the cosine of pi over 25, that almost looks like a 25, times x minus 47.5 plus 5. Let me make that look a little bit more like a 25. Okay? And we'll verify this in a bit. But that's one of them. And that's the easiest one to me. Now don't get me wrong, another good one based on cosine would be shifting it over 22.5 units, but then the a would be negative. Now I'm going to write that one up as well, even though they just said, just give me one based on cosine. Some of you really might prefer this one, and there is nothing wrong with it. That would be x minus 22.5 plus 5. For those of you that are really following along nicely, you might even notice that these two curves, their horizontal shifts, are offset by half a period. Right, the period is 50 units, half a period is 25 units, and that's offsetting those by half a period. That will also always be the case. Now, let's take a look a little bit at a sine curve. Now remember, the sine curve, if a is positive, if we've got a positive a value, has to start at its midline and rise out of the midline. Rise out of the midline. So the first time that we've got a situation where the curve is at its midline and rising out of the midline is right here. The question becomes, what is the x-coordinate there, right? Now we can think about that by taking the x-coordinate here and adding 1/4 of a period. So the x value right here, I don't care about the y value, the y value is 5, right? The x value here is going to be 22.5, this x value, plus 1/4 of a period, 12.5, which is 35. Yeah, it's 35. So the first one that I can really use that where my a value is positive, right, is a horizontal shift by 35 units to the right. So that would give me y equals 20 times the sine of pi over 25 times x minus 35 plus 5. Okay, and let's do one more of them. I know I said only 2, but now we're going to do 4. Because I could also have a sine curve where a was negative. That would be a situation where a is starting at its midline, but then decreasing out of it. Now, in order to do that one, I would have to know the x-coordinate right there. It looks like it's at 10, but let's make sure of that, right? To figure out that particular x-coordinate, I would take this one again, and I would subtract 1/4 of a period. So this particular x value, this guy, would be 22.5 minus 12.5. That is in fact 10, right? So I've got a pretty accurate graph. And I would then have y equals negative 20 times the sine of pi over 25 times x minus 10 plus 5. Okay, and we got them. All right, I'm going to leave it up to you to actually put these in your graphing calculator. We've done that plenty enough now. Put them in your graphing calculator. I would suggest putting all 4 in there. One at a time. Put this one in, get the right window, put this one in, see that it's the exact same curve. Put this one in, again the exact same curve, this one in, same curve. Hopefully they're all the correct curve, but they are definitely all algebraically equivalent based on some stuff that you'll learn in pre-calculus. Okay, let's wrap this up. So today we really looked at determining equations of trigonometric functions based on their graphs. And as I pointed out, right, if you've got a graph and you know a maximum and a minimum that are consecutive, you can then find your midline, your amplitude, your period, and your frequency without doing anything else. Those 4 things can be found immediately and directly, and they don't then depend on whether you're using sine or cosine. Once you have those 4, you then have to make a decision. Is there a horizontal shift? If there is it a shift of sine? Is it a shift of cosine? Right? If it's a shift of cosine, you're going to be wanting to look for your first maximum or your first minimum. If it's a maximum, you'll use an a value that's positive. If it's a minimum, an a value that's negative. On the other hand, sine, you're looking for the first point where the curve intersects its midline. Does it then rise out of the midline, in which case a is positive, or does it decrease out of its midline, in which case a is negative? All of these things, of course, lead to that last problem where we saw 4 different equations, which are just 4 amongst an infinite number, that could describe that particular graph. And it does take a little bit of work, right? I get it. It's probably a bit confusing at this point. I hope at the bare minimum, things like the amplitude, midline, frequency, and period are pretty good for you. The rest of it gets a lot more complicated due to those horizontal shifts. All right, we'll get a little bit more work with this in the next lesson when we use these curves to model real-world phenomena. For now, I just want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.